Okay, here we are. We're going to look at a tricky question that's come up during our sort of preview to the end of unit test that we're doing. Now, this is actually not necessarily a physics question, but more of a maths one. So I think it's a really good one for us to try because maths is a tool that we use in physics a lot. We are dealing specifically with curved motion graphs. So here we are, we've got distance time graph. We've got some information at the top here, and it's not really what we're interested in just now. We're really interested in using this graph to analyze the motion. So don't worry about the mass, etc. just now. Let's think about these questions. We've been asked to calculate the average speed for the whole journey. Now, in this case, we traveled a distance of 4,800 meters. You can read that off the graph. And it took us 120 seconds. Most students get this fairly well. What happens is they say average speed is the total distance divided by the total time. Okay, and they would be right. Okay, all you have to do there is take your 4,800, divide it by 120, and then we get 40 meters per second. So what this says is that on average, if we were to replicate this journey, we would have to travel on average 40 meters per second. Now, hopefully what you can see on the graph is that actually the speed is changing. During the process, we are actually accelerating. We have a low speed at the beginning and then a higher speed later. And that is shown by the fact that this is a curve. Now, in the next question, we're asked to calculate the speed at a specific point, which is 100 seconds. So over here on the right-hand side of our curve. Now, a lot of students at this point simply repeat the process for A, but notice we're missing one word, which is average. We don't want to know the average speed. We want to know what we might call the instantaneous speed. Now, we're expecting our speed at this point to be faster than the average because the curve is at its maximum gradient at this point. So really what the question is saying to you is calculate the gradient. And that's why I said it's about maths at the beginning of this video. At this point, what I want to do is sort of block out or just over half of the picture. Okay, you notice that what we started off with a curve, actually somewhere towards the middle of this process became a straight line. Okay, and why is this of importance? Well, if we want to get the speed, we need to calculate the gradient of this line. And in my lessons, okay, for this course, you will only be asked to calculate the gradient of a straight line. If you go on to IB, you may be asked to calculate something slightly harder. Okay, now I blocked out that part of the curve because hopefully if I ask you to calculate the gradient of this line, it's a little bit easier. In order to do that, what we do is we imagine a triangle and we want to know the height and the base of that triangle. Now, if you just do a little bit of reading on the paper, you should see that, well, the base there is 40 seconds. We're going from 80 to 120. And the height is 2,400. This might take a little bit more believing, but we end at 4,800 and we actually started at 2,400. And the difference between them is 2,400. So nice symmetry in the numbers there. To get the gradient, it is simply the change in y divided by the change in x. So in this case, we're doing 2,400 divided by 40 to get a number which is 60. Now, it is worthwhile taking a second to have a think about what that means. What that means is that at the end of the process, the speed is greater than the average. And that makes sense because we're speeding up during this process. Okay, so we're always going to calculate an average, which is slightly lower than the maximum speed. And that maximum speed is the speed at 100 seconds. So the takeaways here are 1, average speed, we're using the total divided by the total. If we want to know the actual speed, then we need to find the gradient at that particular point, and you will not be asked to do this on any type of line other than a straight one. Okay, but the skill here is to observe where is the line becoming straight and how can I calculate the gradient in a clear way. And as I say, this is a math skill which hopefully you've learned in your math lesson. I should end the video by saying that we can do this for a distance time graph. However, we can also do it for a speed time graph. And in that case, instead of calculating speed with the gradient, you would be calculating the acceleration. but more on that another time. I think this is enough for now. What I'd like you to do is try and use these skills in a couple of follow-up questions. And as ever, if there's anything you're not clear on here, please do ask me. I'm more than happy to help. Thanks for watching.